some initial testing. 2000 millimeters per second, 70k acceleration. Here goes nothing. I think I'm running into some binding issues, that's why I'm just testing the gantries. But first I need to simulate the end stop being pressed and whatnot. I also need to simulate docking now. 100k acceleration, 2000 millimeters per second. Of course, no tool-headed head right now. One Z-axis was binding up and I have identified the issue. I did not grind a flat spot on these shafts. And you can see some scarring where the grub screw from the pulley just kept on turning. And it pushed the rod over even. So now I'm gonna put a flat spot on here and see if that fixes the problem. And if it's fixed, I will of course put a flat spot on all other Z-axes as well. You can clearly see some scarring there. This should not be there. Look how the pulley slowly advanced. Like as it turned, it kept on creeping over. Like a lead screw almost. Now I've ground a flat spot. It's not beautiful. It's kind of ugly, but I think it will work out. Shake tune. The placement of the accelerometer is not ideal, but this is just for like the initial results. Y-axis, shake tune. This is the first time I've ever loaded filament into the machine. I'm just going to extrude some, just to test it out. This is at like 50 cubic millimeters per second. This is now 60. This is the stock Goliath nozzle, by the way. Putting the temperature up to 275 now. This is 60 again. Back to 50. The stock nozzle has some doesn't die as well as it seems. But I'm not gonna run that anymore. 285, 50 cubic millimeters again. And now 60 at 285 Celsius. Does seem to skip steps still. So the stock nozzle really only flows up to 50 cubic millimeters per second of ASA if you don't crank the temperature really high. Now 45 cubic millimeters at 285, this should easily be doable with a stock nozzle. Yeah, no problem. .48. That is still decent. The first ever ASA was melted in this 3D printer. First printer I've started ever. The filament is completely wet, so don't expect any quality. That's good. But it's definitely like extruding something. As I said, the extrusion quality will be really bad. I have not tuned any flow rate or anything, and the filament is super wet, but at least it is extruding. Like it is printing. Like this is the first ever print on this machine. And I don't care if it's ugly as long as it works. It's still progress. I also haven't set up the PTFE tool correctly yet. Looks ugly as a sin, but at least it prints, you know. And this is the first time, first try at least. Like I have never extruded another line via G-code on this printer before. Filament off the spool and I'm extruding from my hand now. I'm definitely gonna mess around with the nozzle. Right now I'm running the stock Goliath nozzle and I'm planning on testing the CHT 0.4 nozzle after this and then running a Volcano CHT 0.4. For that the part cooling will also be updated. This is still using an old modified crown cooler that I just cut part of. Like half of it got cut off, so it fits next to the rail there. But even at like 30%, it does seem to be cooling quite decently. As I said, extrusion multiplier has not been tuned and the filament is really wet. So the print quality was expected to be bad. By the way, this is the first 3D printer I've ever designed myself. The design of this printer is heavily inspired by the NX Engineering's Taicho. That it's supposed to be a Voron cube. Of course, the surface finish is super bad, but I think I can excuse it for a first print. Put a screwdriver and a rubber band on the PTFE tube temporarily, just to like hold it there in place. Of course, that's not gonna be a permanent solution, but at least now I don't have to hold the tube. And I'm planning on running way higher accelerations, but right now I'm kind of current limited because I don't have cooling on the steppers yet, no active cooling. Even with the stock 0.4 Goliath nozzle, we already get quite good flow rates. Of course the quality is bad right now, but we can tune that out. I have no clue why this is so choppy. Like on my 2.4 it's really smooth, but on my V0 it's also choppy like this. Like it doesn't update in real time for some reason. So we've reached the end. There it is, first try, first print ever on this printer. Of course it looks ugly, as I said. Like this filament was literally out in the open for like half a year. Not right. But it printed, you know. So there's that. Can't really ask for more right now. You know? Let's tune this machine and see what it really can do. Because this is definitely not the end point. This is just the beginning. Just running a quick extrusion multiplier test. More pressure advance and extrusion multiplier testing. One issue, the CPAP hose right now is basically falling off, but I already have a redesign that I want to print out. Since last test ran without cooling, I think it will be fine even with it holding on. There it is. I'm gonna print another test cube. This time it's not gonna look like this. already spot one problem. The material spent way too much time in the hot nozzle, and so it discolored for the first layer. So I have to add like a retraction and priming to the start and end G-coat. Acceleration limited. Like we could flow way more filament, we have way more cooling, but the acceleration limits the top speed we can reach right now. But I definitely have a plan for that. Second cube done. Still need to tune some parameters, but this one is already way better. Now after these two cubes here, I'm printing another one. Right now, as I said, we are still heavily acceleration limited. So at like 30k, we basically never hit the requested speeds. So I plan on pumping way more current into the steppers to get some higher acceleration. Because this hot end has way more flow rate, and the cooling is also not even halfway turned up, and the hose is not even connected properly, and it still works. So there's definitely a lot of headroom, but I still wanna see what it can do. The motors at 2.8 amps without active cooling are only running at 77 C right now. Thanks to Matt, the 3D printing nerds, the OS custom clipper distribution, which has TMC, basically all TMC parameters are optimized. And because the values are automatically calculated, they are way better suited for the 2800s, for example. They overheat with stock clipper very fast. I don't think that I could have run these steppers without active cooling at 2.8 amps in a hot chamber. I think they would have overheated like really fast. And I still need to do something about the end of print G-code. Because right now it kind of like sits there and then drags across the print, which is not very nice. So I probably just have to make the Z go down. And even in harsh lighting, this one looks better than the last one. If you need some metal parts for your 3D printer, check out PCBWay's offerings. It's quite easy. You just upload your part, configure a few parameters, and you get an instant quote. After that, an engineer will inspect your part and analyze if it can be manufactured or not. If it cannot, the engineer will also give you advice on what could be changed to make it manufacturable. After that, it's quickly produced and also rapidly shipped worldwide. If you need some CNC machined parts, maybe milled, maybe turned, even up to 5-axis milling, there's a wide selection of materials you can choose from. Again, the filament's wet, that's why it's a little bubbly. But this wood is almost empty, so I didn't really want to dry it again. So this is 6 minutes benching. Not a speed benching, just for decent looks. But also with decent speed. And she looks pretty clean, but the top still has some cooling issues. printer is mostly meant to print functional parts and prototypes. I'm going to print a dragon burner cowl now. I hope it looks decent, and it's quite fast. This is 3D Jake ASA, by the way. Eventually I'm going to run more acceleration, because the motors, they're not even at 80 Celsius right now. But first I need to add the cooling fan. I have to machine the back panel first. It needs a cutout for the fan. After this one I'm going to print a high flow application with almost 100 cubic millimeters per second if it works out. printed in under 20 minutes. Compared to the earlier print, this print is not gonna be very detailed, but it's gonna have a lot of flow. Almost 100 cubic millimeters per second through a 0.4 nozzle. This is a CHT 0.4 nozzle. Eventually I plan on putting a Volcano CHT into here, but it's gonna require some redesigning. Right now I'm also running a modified crown cooler. It's partly cut off. And I want to at least update to the newest iteration of the crown. Or something else, I don't know yet. Sometimes it goes up to 95, but it's only really short bursts. Because the cubic infill only has very few lines that are actually long enough. But you saw a 91 there for a second. So the peak flow is actually 95. But it's not sustained. Peak sustained flow is probably around 75 maybe. Right now. For this print. Motor's only at like a little bit above 80. This here right now is the filament dry storage unit, still in development. I'll post an update on it, so maybe you recognize some of the parts in there from an earlier video. thanks to PCBWay for sponsoring this video and providing these SLM 3D printed aluminum heatsinks. If you need some metal parts for your 3D printer, or maybe for your CNC, go check out their services. The pressure advance is a little off right now, because I just used the same value from the other light gray material. But it's still good enough for now.